Do you know what the unsafe keyword means in C#? How about in and out on a generic type parameter? Well, today we're looking at 5 features of C# that not many developers use, but they can be extremely useful. So get ready to impress your friends, your colleagues, and your family with your in-depth knowledge of C#, and let's jump into these 5 hidden features of C#. And we're going to start off with in and out. The in and out keywords look like this. These keywords go alongside the generic type parameter when you're declaring a generic interface or delegate, and they're used to specify variants. What is variants? Well, this probably warrants an entire video by itself, so maybe I'll make that in the future. But in a nutshell, variants allows you to assign a more derived type to an interface of a base type. Covariants and contravariants are the 2 terms that describe specific types of variants, and the in and out keywords are used to implement them. Covariants, using the out keyword, this enables you to use a more derived type than originally specified. So the IEnumerable interface is covariant. You can assign an instance of IEnumerable string to a variable of type IEnumerable object. Because string inherits object, this works. If this interface didn't support covariants, then you wouldn't be able to do this. So the actual definition of the IEnumerable interface would look like this. You can use the out keyword to make your own interfaces covariant. So in this example, the interface iCovariant uses that out keyword there. So doing this means that we can assign a list of dog objects to a list of animal objects. And of course, this means if you have a function that accepts an argument of type covariant animal, then we can pass in an instance to the function, and that will work just fine thanks to covariance. The in keyword is the complete opposite. The in keyword allows contravariance. Contravariance enables you to use more generic, so less derived types than the original that was specified. So you have covariance with the out keyword and contravariance with the in keyword. Here you can see we're assigning an instance of the generic that uses the base class animal to a variable that needs the more derived version called dog. To assign the dog to an animal generic class, you need covariance, and to assign the animal to a dog, you need contravariance. Okay, number 3 is pattern matching. Pattern matching was introduced in C# version 7, and it extends the functionality of the switch statement by using the when keyword. So this allows you to have more expressive checks against the shape and the type of the data, rather than just the value. So the basic syntax of pattern matching looks like this. It's a switch statement with individual cases for each pattern. And the when keyword here can be used to apply some conditional logic to individual cases or patterns. Here's a few examples. This example matches based on the type of this object. So we have a case for integers and then a different case for strings. This example here uses the when keyword, which is something called a guard statement. So it'll only drop into this case when that condition is true, i.e. the number is greater than 40. Lastly, here's an example of a property pattern matching. And this is again a pretty new feature in C#, but given that we have this person class here with 2 properties, then we can create an instance of the person class and match on that. So when we actually specify values for these properties inside the case statements like this. So here we're saying drop into this case if the age is less than 20. This is pretty cool because previously you might have been tempted to create a load of nested if statements to do this, but using pattern matching just gives you more options and can often lead to much more straightforward code. Next up, we've got using static. This is a directive in C# that allows you to import the static members of a type so that you can use them without qualifying them with the type's name. So for example, you probably use the using statement to make types in a namespace available in your code. Well, this means that you can directly use types from the system namespace, for example, like console, without having to qualify them. So you can call console.writeLine basically without having to do system.console.writeLine. Well, using static allows you to take that step further and lets you actually use static methods, properties, or fields of a type without qualifying them at all using the type's name. So if I do using static system.console, I can just call writeLine here, and that will compile. Using static can lead to more concise and readable code in certain situations. But again, like everything on this list, just be mindful about when you're using this and think, is it really about making your code more understandable, or is it just making things more complicated? Now, the next couple of features on this list are all to do with low-level memory management. And the first one is a pair of keywords called safe and unsafe. These keywords are used to indicate whether a block of code contains unmanaged code that directly accesses memory using pointers. So by default, C# code is safe, which means it doesn't allow direct memory access using pointers. There are scenarios where you might want to use pointers for performance reasons or when working with native libraries, and so the language does give you the option to jump out of this managed context and into an unmanaged or not memory safe context. So here's a breakdown. Safe code is the default mode in C#. The .NET runtime does all of the memory management, ensuring that you don't access memory that you shouldn't be accessing. Unsafe code, on the other hand, does allow you to use pointers in C#, so you can access memory directly, similar to how you'd do it in languages like C or C++. This can be dangerous if you're not careful, hence the name unsafe. So for that reason, before you can use unsafe code in C#, you need to enable the use of unsafe code in your project. So in Visual Studio, this is done by right-clicking on the project in the Solution Explorer, choosing Properties, and then Build, and then checking Allow Unsafe Code. So there you can use the unsafe keyword in your project. Here's an example. Let's say we have an array of integers and we want to use pointers to iterate through the array and double each value. So in this function here, we've used the fix statement, which pins a variable's location in memory, preventing the garbage collector from moving it. This is necessary because we're dealing with pointers and we don't want the memory location to change unexpectedly. The pointer PTR points to the first element of that array. We then use the pointer arithmetic to iterate through the array and double each value. Now I appreciate this can seem a little bit overwhelming if you haven't done memory management before, but if you want me to make a full video on managing memory yourself in C#, then let me know in the comments below, and I think this would be a really fun thing to do a deep dive into one day. But for now, let's move on to the next advanced feature of C#, and that is stackalloc. When we're in an unsafe context, the stackalloc keyword can be used to allocate a block of memory on the stack. So whereas object instances are usually given heap memory, this can let you specify that you want them to live on the execution stack of your program. So this can be a useful technique for creating small arrays or buffers without causing heap allocation, which in turn avoids the associated garbage collection overhead. So it's absolutely critical to remember though that since the memory is allocated on the stack, it has a limited lifetime, specifically the duration of the enclosing method's execution. Here's a quick example. In this example, we've allocated memory to the 3 integers on the stack. So notice that this code is wrapped in the unsafe block, indicating the usage of pointers which aren't under the managed environment safety checks. So this is proper low-level memory management stuff, and it feels a lot more like C++ than C#, but it's cool to know that C# does actually let you do this kind of thing if you really, really, really wanted to. Also, starting from C# 7.2, stackalloc can be used with the span type, so you don't need to use unsafe like in that previous example. Span provides a type-safe and memory-safe representation of a contiguous region of arbitrary memory. So this code does the same thing as the earlier example, but it uses span instead of a raw pointer. This approach is generally safer and it's recommended over using raw pointers when possible. So C# is a versatile language that caters to a broad range of developer needs, from high-level object-oriented design to low-level performance optimizations. And remember that while these features can provide solutions to specific problems, and they can certainly impress your peers, it's crucial to use all this stuff appropriately. Just because you can mark all your code as unsafe definitely does not mean that you should. The primary goal is always to write code that's clear, maintainable, and efficient. So always consider the implications, especially when dealing with unsafe code, and ask yourself if there's a safer or more straightforward alternative. If you found this video helpful, please sure to give it a thumbs up and subscribe to Change the Code for more in-depth tutorials and explanations. As always, if you have any questions on topics you'd like to see covered in the future, chuck them in the comment section below. And until next time, my name's James Charlesworth, and I'll see you soon.